So welcome everybody to this latest revision video on 162 Maths, and in this video we'll be continuing on the theme of revising and preparing for the AQA GCSE Maths of 2022 using the advanced information to look at paper 2 on the higher of geometry and measure. Now, as always, there'll be a copy of the question paper in the as a link in the description below for you to download and have an attempt at either before watching this video or while watching this video as we go through the answers. So before we get started on some practice questions, let's just have a quick look at the advanced information given about paper 2 on the higher GCSE Maths of 2022 geometry and measure section. So looking at the first one of compound shape. So compound shape is basically a shape that is made up from smaller known shapes, and this could be either be 2D or 3D. So for example, a combination of triangles and rectangles, or semicircles and rectangles, or triangles and cubes and pyramids and cones and cylinders, etc. Now, when it comes to cones and hemispheres, this is more than looking at 3D models, in which then you're either going to be looking at the surface area or the volume of a cone and hemisphere. And that could also be linked with compound shapes as well, because obviously you can link a cone to a hemisphere. Now, with regards to formulas of these, now because they are classed as higher level sort of shapes, most likely you are going to be given the formula for the cone and the for a sphere. Hemisphere, not so much. All you've just got to remember that a hemisphere is half a sphere. And then in terms of the formulas, the volume of a cone is a third pi r squared h. The curved surface area of a cone is going to be pi r l, where l is the diagonal, again linked with Pythagoras. So again, another topic that's mentioned in this section. And obviously for the total surface area, you just need to make sure that you are including the base. For the volume of a sphere, it's a 4/3 pi r cubed, and the surface area of a sphere is 4 pi r squared. So just make sure that you are familiar with those formulas and know how to use it. With regards to volume scale factor, the key thing to remember here is that you are going to be given a scale factor of another sort. So if the length scale factor is k, then the area scale factor, including surface area, is going to be k squared, and the volume scale factor is going to be k cubed. So always make sure that you have got the correct scale factor and you're using the correct scale factor when working with these questions. With regards to plans, this is going to be linked to plans and elevation isometric drawing. So remembering how to draw either the plan, the side, or the front view of a 3D shape that's been drawn for you. When it comes to Pythagoras, again, there's a number of combinations. It's always going to be expected this to come up on a GCSE paper. So make sure that you're able to work with labeling the triangle first. Know how to find the small and the big side. Contextual problems is more worded problems, working with 3D problems and coordinates as well. When it comes to time, there you're probably looking at converting time units. We'll also maybe potentially looking at time series graphs. I would say time distance, but I think they would have specified that as time distance if that's what you were using. But I would say converting time units is probably going to be the most useful, the one that's going to be most likely to come up. Also working with time questions, like working the difference between times, questions could come up there as well. With regards to geometric proof, this could be a range of topics. So this could include circle theorems, working with angle proofs, so working with parallel lines, perpendicular lines, etc., and all those facts of corresponding, alternate and supplementary or co-interior. Also working with congruency questions, similarity, and also vectors as well. Now vectors, I would say, is less likely. I think they would have mentioned that as a separate unique topic if the geometric proof question was going to involve that. But I would say most likely it's going to be either related to angles, circle theorems, congruency, or maybe similarity. So before we get started working through some revision questions, just a little quick note that if you're wanting access to this question paper, then all you need to do is just click on the link in the description below and you'll have it. And you can either practice these questions before watching this video as we go through the answers, or you can have a go at doing them while watching this video. So looking at question 1, it says that Alex has a solid paperweight made from a cuboid and a sphere as shown. The diameter of the sphere is 3 centimeters. Show that the volume of the paperweight is 62.1 centimeter cubed to one significant figure. So for this, what we need to do is we need to work out the volume of these two shapes, which I'm just going to call A and B. So for the volume of the sphere, now I think this is an older question, but basically the formula I need to use is going to be 4/3 times pi times r cubed. Now here the diameter is 3, so it means that the radius therefore is going to be, so if the radius is 3, then that means that the radius is going to be 1.5. Then substituting numbers in, what do I get? Well, I get 4 over 3 times pi times 1.5 cubed. And if I type that all into my calculator, let me just work out what I get. And where possible, try and use the fraction button for 4/3 just to make your answer that a little bit more accurate. And what we get for the volume is 9 over 2 pi. Now I'm going to leave my answer like that in this due course, but if you wanted to write it as a decimal, it would be 14.137166694. We then need to work out the volume of the cuboid. So the volume of the cuboid is just going to be multiplying all the 3 dimensions together. So here it's going to be 6 times 4 times 2, which gives me an answer of 48 centimeter cubed. Then from this, all I then need to do is the volume of the sphere, the paperweight is going to be, so the total volume is going to be 9 over 2 pi plus 48. And if I type that all into my calculator, I get an answer of 62.137166694. And that rounded to 1, that's 3 significant figures, is going to be what they've asked me to prove. And there we go. So then moving on to our next question. So it says that Alex thinks the paperweight is made of lead. He knows that the mass of the paperweight is 540 grams and the density of the lead is 11.3 grams per centimeter square cubed. Is the paperweight made of lead? So let's have a look at what we've got here. So he knows that the mass of the paperweight is 540. So here what we've got is that the density equals mass over volume. So substituting numbers in, we've got 540 over the volume, and that all equals 11.3. So from this, I then get V equals 540 divided by 11.3. So V equals 540 divided by 11.3, and that comes up to an answer of 47.47876. And so is this the same? So no, it is not made of lead. And the reason for that is because 47.8 is not equal to 62.1. Moving on to question 2, it says, so here this is where it uses a cone and a hemisphere. So it says a small toy is made up by joining a solid cone and a solid hemisphere together. The cone and the hemisphere each have a radius of 6 centimeters. And the question is asking us for part A is show that the volume of the toy is 312 pi. So here we've got A and B. So the volume of, so looking at A, of the cone is going to be equal to, now the volume of a cone is 1/3 pi r squared h. So from this, what we then got to do is look at to make sure we've got the dimensions. Now this here is h. Now you might think to yourself, oh, I might need to use Pythagoras because here we've got a right angle triangle, but if the radius of the hemisphere is 6, then that means the height of the hemisphere is also going to be 6. So then if I then do 20, take away 6, I get 14. So from this, I've then got all the right information I need to work out the volume of the cone. So it's going to be 1/3 times pi times 6 squared times 14. And if I type that all into my calculator, which I'm going to do right now, I get an answer of 168 pi. So then if I then work out the volume of the hemisphere, and the formula for that is going to be 4/3 pi r cubed divided by 2, and again divided by 2 because I've got a hemisphere. So then substituting the numbers into that, I get 4/3 times pi times 6 cubed, all divided by 2. And again, if I just quickly type that into my calculator, I get an answer of 144 pi. So then all I then need to do is add those two numbers up. So the volume total is going to be 168 pi plus 144 pi, which gives me an answer of 312 pi centimeter cubed, which is what they wanted me to show. Now moving on to question 2b, it says the larger version of the toy is made that has the dimensions is twice the size of the small toy. The mass has a mass of 1.5 kilograms. The toy is made from foam. Work out the density of the foam. Give your answer in grams per cubic centimeter. Now there's a couple of things in which we need to be aware of, and obviously as this is a 4-mark question, it's not going to be as easy as we know. So here we want to work out that the density is going to be in grams per cubic centimeter. So the volume needs to be in cubic centimeters and the mass needs to be in grams. So here let's first of all convert 1.5 kilograms into grams, so it's going to be 1500 grams. Now looking at this first statement, which says the dimensions are twice the size of the small toy, so here what we've got is we've got that the length scale factor is going to be 2, so therefore the volume scale factor is going to be 2 cubed, which is 8. So the volume of the large toy is going to be 312 pi multiplied by 8, and if I do that on my calculator, so I get 312 pi times 8, and that gives me an answer of 2496 pi. So from this, what I can then do is then work out the density. So the density is going to be the mass, so remember that D equals m over v, so the mass is 1500 over 2496 pi, and if I type that into my calculator, I get an answer of 0.19, and that's in grams per centimeter cube, and that is rounded to 2 decimal places. Moving on to question 3, it says the volume of a cone is 1/3 pi r squared h, where r is the radius and h is the perpendicular height. A cone has a horizontal base of 5 centimeters and a height of 15. The cone contains water with a depth of 9 centimeters. Work out the volume of the water in centimeter cubed, and we need to give our answer in terms of pi. So for this, what we need to do here, so the volume of the water is equal to the volume of the cone, the big cone, minus the volume of the small cone. So from the big cone, what we've got, so using this formula here, I've got 1/3 times pi times the radius, which here is going to be, now looking at this, what I need to do is to use a bit of similarity. So if the height of the small cone is going to be 15 take away 9, which is 6 centimeters. So then from this, what I can then do is that the length scale factor is going to be 15 divided by 6, and then which is going to be 5 over 2, which is 2.5. So then this length here then, so the radius of the small rectangle is going to be, so the radius of the small cone is going to be 5 divided by the scale factor, which is 2.5, so that's going to be 2 centimeters. So then going back to the big cone, it's going to be 1/3 times 5 squared times the height of this, which is 9, or of the big cone, which is 15 rather. And so typing that all in, what do I get? Well, I get 1/3 times pi times 25 times 15, and that gives me an answer of 125 pi. Then if I then do the small cone, That's going to be a third times pi times 2 squared times the height, which is 6 centimeters. And again, if I type that all into my calculator, let me just quickly do just that, I get 8 pi. So then the volume of the water is going to be these two lengths, these two measurements subtracted from each other. So 125, take away 8 pi, and that leaves me with 117 pi. And that's in centimeter cubed. Then moving on to question 4, it says that a paper filter is in the shape of a hollow cone with diameter of 22 and a slant height of 18. And the question is asking to work out the area of the paper used to make the filter. Now here, with it being a paper filter, we don't need to work out the area of the circle. So it's just this slant area here that I need to work out. So here the surface area is going to be equal to pi r L, where this length here is L. So then all I then need to do is pi times the radius. Well, if the diameter is 22, the radius is going to be 11 times 18. And if I type that all into my calculator, I get pi times 11 times 18 gives me 198 pi. But as a decimal, it's going to be 622.035 blah 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 centimeter squared. But the question is asking me to give my answer in 2 sig fig, so it's going to be 620 centimeter squared, and that's just 2 significant figures. Moving on to question 5, it says that this right circular cone has a radius of 2p and a height of 5p. The dimensions are written in centimeters. The volume of the cone is 22,500 pi centimeter cubed. Work out the value of p. So for this, the volume of the cone is going to be a third pi r squared h. So this here is h, so h equals 5p and r equals 2p. So then what I'm then going to do is substitute this and this into this formula. So what I've got is I've got a third times pi. Instead of using r, I'm going to use 2p, so it's going to be 2p squared. And instead of using h, I'm going to use 5p. And that's all equal to 22500 pi. So simplifying the left-hand side, I get a third times pi times 4p squared times 5p. And then neatening all of this up, I end up with 20p cubed pi all divided by 3, and that equals 22500 pi. And from this, what I could then do is to cancel the pi's, because I've got pi on both sides. I can take the 3 over to the other side, so I end up with 20p cubed equals 22,500 times 3, which is 67500. I can then take the 20 over to the other side, so I end up with p cubed equals divided by 20 equals 3375. So p equals the cube root of 3375. So p equals, and just type that into my calculator, gives me an answer of 15, and it's going to be in centimeters. Then moving on to question 6, it says here are two similar solids A and B. The volume of B is 400. Is the volume of A approximately 1/4 the volume of B? So for this, what we need to do first is work out the volume of A. So looking at this, we need to know that the length, well, we know that the length scale factor is going to be 8/5. So that means then the volume scale factor is going to be 8/5 cubed, which is 512/125. So that means then the volume of A, because we're going from big to small, is going to be 400, which is the volume of B, divided by 512/125. Now if I then work that out on my calculator, so 400 divided by 512 divided by 125, it gives me an answer of roughly around about 97.6 5625. Now this is approximately 100. So therefore, is that then a quarter of, well, quarter of, I don't know what that 4 looks like, so let's just get rid of that. And so quarter of 100, 400 is 100. So you could see that yes, it is approximately. So yes, the volume of A is approximately 1/4 of B. Moving on to question 7, it says here are two solid shapes that are similar. The volume of A is 1400 centimeter cubed. Work out the volume of B. So again, looking at this, we can see that the length scale factor, let me just get rid of all of that. So here the length scale factor is going to be 15/12, which can be simplified by dividing both numbers by 5, but again, not essential on a calculator paper, so that's going to be 5/4. So that means that the volume scale factor therefore is going to be 5/4 cubed. So then to work out the volume of B, I need to go from small to big. So the volume of B is going to be 1400 times 5/4 cubed. And if I type that all into my calculator, I'm going to get an answer of 2734.375. And again, I just want to round this number up if I wanted to. So 2734.4, and that's been rounded to 1 decimal place. Moving on to question 8, again another volume scale factor question. So it says that a solid cylinder has a volume of 454 centimeter cubed. The cylinder has a height of 10. A similar cylinder has a height of 15. Work out the volume of the larger cylinder. So again, here we're looking at the length scale factor is going to be 15/10, which is 1.5. So then the volume scale factor then is going to be 1.5 cubed. So then if we know that the volume of the smaller one is 454, so then all I then need to do is the volume of the large is going to be 454 times 1.5 cubed. And again, typing that into my calculator, I get an answer of 1532.25. And then moving on to question 9, it says this shape, a solid shape, is made from identical cubes on the grids. Draw the side elevation from L and R and the plan view. So for L, it's going to look like an L shape. So that's going to pretty much look, again, you should be using a ruler just so that you don't fall asleep watching this video. That there is going to be L. R is going to be the reverse of that, or the reflection of that. That looks something like this. And the plan view, again, could look like this. And if your sort of spikes are going in the opposite direction, then that should be fine. But I would say something along that, but more neatly drawn with a ruler and a pencil, should get you enough for the marks. Now, if you flip that in terms of the way, that should also get you the mark as well. Moving on to question 10, so it says this diagram shows a rectangle inside a semicircle. The rectangle has dimensions of 16 by 6. Work out the shaded area and give your answer in terms of pi. So let's have a look at labeling this up. So this length here is 16 and this length here is 6. Now what I need to do is I need to work out what the radius of the circle is, because I know what the area of the rectangle is. So here the shaded area is going to be equal to the area of the semicircle minus the area of the rectangle. Now the area of the rectangle is just simply going to be 16 times 6, which if I type that into my calculator, I get an answer of 96. But for this, what I then need to do is this. Now from this, I notice that this is a right angle triangle. This is 8, this is 6. So working out r, so r squared equals 6 squared plus 8 squared. So this is where Pythagoras comes in. So I've got 36 plus 64 is 100. So r squared equals 100. So r is going to equal 10. Now it's not going to equal minus 10 because you can't have negative length. Therefore, then the area of the semicircle is going to be pi r squared divided by 2. So it's going to be pi times 100 divided by 2. So then the shaded area, therefore, is going to be 50 pi minus 96. I'm going to leave my answer like that. So then looking at question 11, it says the diagram shows a right angle triangle, and it says 4 of these triangles are used to make the shaded square as shown, and the question is asking us to work out the area of the shaded square. Give your answer in third form as simply as possible. So first things first, what we need to do is work out what this length here is. So if I just call that x, then to work out x, I'm going to do x squared equals 6 squared minus 4 squared. So x squared is going to equal 36, take away 16. So x equals root 20. So from this, what I then know is that all of this distance here is root 20. And this distance here is 4. So that means that this distance here must be root 20 minus 4. Now if that's the length of a square, then the area of the shaded square is going to be root 20 minus 4 squared. Now because it's a calculator paper, I could just simply type that into my calculator, but it's basically recognizing it's going to be root 20 minus 4. Now you can write root 20 as root 4 times 5, which is 2 root 5. But again, I'd leave it as that. And if you type that all into your calculator, then you should get 36 minus 16 root 5, and that's centimeter squared. Now, one thing you could do is you could factorize it. So you could factorize it with respect to 4. So if I take, let's get rid of that there. So here I've got 4, and it's going to be 9 minus 4 root 5 centimeter squared. But again, not necessary. I'll probably leave my answer as 36 minus 16 root 5. Moving on to question 12, it says that a runner starts at A and she follows the route A to B to C to D to A. The 3 distances are shown on the diagram, and the question is asking to work out the distance in kilometers of D to A. Now for this, what we need to do is this is going to be a 2-step Pythagoras question. So we've got 2 right angle triangles. So if I start off by working what B to D is, well, B to D squared is going to be 2.5 squared minus 2 squared. So B to D squared is going to equal, and if I type that into my calculator, I get an answer of 2.25. So B to D is going to equal the square root of 2.25. Now I'm going to leave that as it is, and again, I'm just going to label it on the diagram. So then to work out what A to D is, which is what the question's asking me to find, A to D, now that is the long side of the triangle ABD. So it's going to be AD squared is going to be equal to 3.4 squared plus root 2.25 squared. So AD squared is going to equal, and if I type that all into my calculator, I get an answer of 13.81. So then A to D is going to be the square root of 13.81, which gives me an answer of 3.716. So 3.7, and that's to 1 decimal place, and that's kilometers. So then moving on to question 13, it says that a triangular plot of land is for sale. It says the land is sold for 6,400 per acre. 1 acre is 4,047 meters squared. Work out the cost of the land. So first things first, what we need to do is to work out the area of this triangle, and in order to do that, I need to work out what this length here is, which I'm going to call h. So h squared equals 80 squared minus 64 squared. So h squared equals, and I'll quickly type that into my calculator, and I get an answer of 2304. So h equals the square root of 2304. So I'm working out the area, and that's going to be using half base times height. So that's going to be root 2304 multiplied by 64, all divided by 2. Now just make sure that when you are doing the square root, that only the 2304 is under the square root, not the 64. So then if I then type that all into my calculator, times 64 divided by 2, it gives me an answer of 1536, and that's in meters squared. So the next thing I then need to do is convert that into acres. So from this, what I've then got to do is, so in acres, it's going to be 1536 divided by 4047, which gives me an answer of 0.37954 blah blah blah, and that's in acres. So then what I then need to do is multiply that by 6,400. So if I do 0.3795404,003, now you could have rounded that, but if I multiply that by 6,400, I get an answer of 2,429 and 6 pence. Now the reason why I use the exact value is just because I want to give my answer as accurate as possible, but I've just noticed that they want the answer to 2 significant figures. So that rounded to 2 significant figures, which is going to be to the nearest 100, is going to be 2,400, and that there is 2SF, not 3. Let me just finish by writing that. Moving on to question 14, it says work out the value of x. So again, I've got to use Pythagoras again. So this is my C, this is my A, this is my B. So what I've got is I've got 8 squared plus 2x minus 1 squared equals 2x plus 1 squared. Now recognizing that 2x minus 1 squared is 2x minus 1, 2x minus 1, which expanding the brackets is going to give me 2x squared minus 4x plus 1. I then do 2x plus 1 squared, that's 2x plus 1, 2x plus 1, which expanded gives me 4x squared plus 4x plus 1. So substituting all of this into this line, what I end up with is 64 plus, and then it's going to be 4x squared minus 4x plus 1 equals 4x squared plus 4x plus 1. And then from this, what I can then do is start to cancel things out. So I've got positive 4x squared on both sides, so they cancel out. If I then take this 4x over to this side and this 1 over to that side, I end up with 64 plus 1 minus 1. And on this side, I end up with 8x. So here, what I end up with is going to be 64 equals 8x. So x equals 8, and that's in centimeters. Moving on to question 15, it says Samir and Dan run a race. Samir finishes in 2.5 minutes. Dan finishes in 130 seconds. Complete the sentence. So-and-so wins by so-and-so seconds. Now, because they want the answer in seconds, it makes more sense for me to convert Samir's time into seconds. So it's going to be 2 lots of 60 plus 30, which is 150 seconds. So then comparing the two times, who finishes with a quicker time? It's going to be Dan, and that's going to be by 20 seconds. Then moving on to question 16, it says that Alice does a sponsored walk. She starts from home on Monday at 8 a.m. and she arrives back home 55 hours later. Work out the time when she arrives back home. So here what we need to do is take away the days from 55 hours. So here it's going to be 55, take away 24, take away 24. So that leaves me with 7 hours. So it's going to be 2 days and 7 hours. So then if I count 2 days from Monday, so that's going to be Wednesday. And then if I add 7 hours to 8 a.m., I end up at 3 p.m. or 15:00. And then question 17 says circle the length of time between 1:50 p.m. and 3:35 p.m. and the correct time you should have is 1 hour and 45 minutes. Moving on to question 18, it says how many minutes are there in 225? For this, all I need to do is divide by 60, then simplify the fraction, in which I could easily do this on my calculator, which simplifies it for me, and it should be 15/4. And if I press Shift SD, if you've got a Casio calculator, that's going to be 3 3/4, which is our last option. Moving on to question 19. So this is where we start moving on to geometric proof. So it says ABCD is a quadrilateral. Prove that ABCD is not a cyclic quadrilateral. Now, if a cyclic quadrilateral, then opposite angles should equal 180 degrees. So what I need to do is I need to work out the values of x. Now here I know that all angles in a quadrilateral add up to 360 degrees. So if I add up all of these angles, so 4x plus x plus 36 plus 92 plus 5x plus 30 equals 360. So then simplifying all of this, I've got 4x plus x plus 5x, which leaves me with 10x, plus, and if I do 36 plus 92 plus 30, gives me an answer of 158. Now from this, I can then work out the value of x, so 10x equals 360 minus 158, which is 202. So x equals, and that's going to be 20.2, which seems a bit odd, but there you go. So now if I work out what angle this is going to be, so angle A is going to be 4 times 20.2, which is 80.4, and angle C, which is going to be 92. So as 80.4 plus 92 does not equal 180, the quadrilateral ABCD is not a cyclic quadrilateral. And that should be enough to get the 4 marks. So now let's have a look at question 20. So question 20 says that A, B and C are points on a circle, CD is a tangent, and it says that to assume that the triangle ABC is isosceles with AC equaling BC. And the question is asking us to prove that AB is parallel to DC. Now with these questions, communication is really, really important. It's important that you include in your answer really good detailed content as to what you're assuming, what you're using and what you're finding. So let's first of all mark what the question has told us. So it tells us that the triangle ABC, which is the triangle inside the circle, is isosceles. So this side here is going to be equal to this side here. Now in terms of initially stating a statement, well, if A and B are parallel, then what you've got to do is you've got to think about angles in parallel lines. And the one that comes to mind is probably alternate angles, because I can see a Z. So the two lines in question that I want to prove are parallel is this line here is parallel to this line here. And if that is the case, so if AB is parallel to DC, then angle BAC is going to equal ACD, as they are alternate angles. So this is the general proof that I'm going to be using. Now there are several other ways in which you can do this, but this is the way that comes first to mind with regards to me. So, but again, there are other ways in which you can do this. Now, as long as you are making, let's say, 4 points, then that's going to be absolutely fine. So sticking with this, what we then got to do is work through the angles. So from this, we know that as DC is a tangent, then this angle here, which is ACD, is going to be equal to ABC. And the reason for that is because of the alternate segment theorem. So this angle here is the same as this angle here. Now in terms of the next thing I'm then going to say, so as ABC, or triangle ABC, is isosceles, then this angle here is going to be the same as this angle here. So if I then just put a little symbol on there, so therefore is isosceles, then angle BAC is going to be equal to ABC. So therefore then, if these two angles, if that's also going to be orange and this angle is going to be orange, so therefore as BAC is equal to BAC, which is also equal to ACD, then AB is parallel to BC. And again, let me just reiterate what that basically means. So if basically what we've done is we've proved that this angle here is the same as this angle here because of the alternate segment theorem. Now because it is a isosceles triangle, ABC is, that means that this angle here is going to be the same. So all these green angles are the same. Now what you've then got to remember is that if AB and DC are parallel, then we should have a Z angle, in which this angle here needs to be the same as this angle here, which we have then gone on to prove is the case. So moving on to B, it says in fact ABC is equilateral rather. Tick the two boxes for the statement that must be correct. Now the two that you must tick are going to be the first two. So AB is parallel to DC, which we've proved, and AC bisects the angle BCD. Moving on to question 21, so let me just zoom out a little bit. So it says ACDE are points on a circle. CE is equal to DE. The tangent at D is shown. ACD and BCE are straight lines. And the question is asking us to prove that y equals 3x. So again, looking at this, what we've got to look at is whenever you see a tangent, automatically think alternate segment theorem. So if this angle here is 4x, then which angle is going to be the same as that? Well, it's going to be this angle here. So this angle here is also going to be 4x. Now because this triangle is isosceles, then to work out what this angle here is, well, that's going to be 180 minus this angle here, which is 4x, and divided by 2, because that angle is the same as this angle here. Now simplifying all of this, I've got 180 divided by 2, which is 90, and 4x divided by 2, which is 2x. Now this angle here is also going to be 90 minus 2x, and the reason for that is because they are opposite. So what we've then got is if we take this triangle of ABC, this triangle here, and if I just quickly do a little sketch. So this is y, this is 90 minus x, and this angle here is 90 minus 2x. Then all of these three angles need to add up to 180. So I've got y plus 90 minus x plus 90 minus 2x equals 180. So expanding the brackets, I get y plus 90 minus x plus 90 minus 2x equals 180. Well, these two things cancel, so I'm left with y minus 2x, 3x rather, equals 0. And then if I take the 3x over to the other side, I end up with y equals 3x, which is exactly what they wanted me to prove. Moving on to question 22, it says P, Q, R and S are points on a circle. P, X, R and Q, X, S are straight lines. PX equals SQ. And the question is asking us to prove that QS is not the diameter of the circle. So let's first of all think, well, if it's the diameter, and we're looking at circle theorems, so if QS is the diameter, then angle QPS equals 90 degrees. So this is the general rule that I'm going to be investigating. I want to show that this angle here is not 90 degrees. So let's have a look and go about finding this. Well, I know that this angle here is going to be 27. And the reason for that is because we've got a bow. And then looking at these two angles here, well, because the triangle PXS is a isosceles triangle, those two angles are going to be the same. So to work out this angle, I've got to do 180, take away 50, divided by 2. So that leaves me with 130 divided by 2, which equals 65 degrees. So therefore then, the angle QPS is going to be 27 plus 65, which equals 92 degrees. So as QPS is not equal to 90 degrees, QS is not the diameter of the circle. Moving on to question 23, it says ABCDE is a pentagon. Show that BCDE is a parallelogram. So here what we need to do is set up a sort of stating like a geometric statement. So if BCDE is a parallelogram, then BC or BE is parallel to CD, and that BC is parallel to ED. Obviously I need to have two sets of parallel lines. Now if it's parallel, then basically what we're looking for with vectors is looking at factors or multiples. So what I've got to do is show that the vectors of BE and CD has a common multiple or common factor, and BC and ED have a common multiple or common factor. So what I need to do is I need to find out the vectors of each of these four lines. So looking at B to E, we know that B to E, what I've got to do is going to be A plus 2B, and I can't simplify that. And C to D, which is here to there, is going to be minus B plus 2A, because I'm going in the opposite direction of the arrow. Then I'm going again from E to D, so I'm going to be doing minus A plus 3B. And if I simplify all of that, well, I've got 2A minus A, which is A, and minus B plus 3B, which is plus 2B. So here what I've got is I've got B to E equals 1 times C to D. So therefore BE is parallel to CD. So then, and also because I haven't got a shared letter shows that they're not on a straight line either. So moving on to my next proof, let's then look at B to C. Well, B to C is going to be A plus 2B plus B minus 2A. So what do I've got? Well, I've got 3B minus A. And then I need to then work out what E to D is. So E to D is A minus 3B. So then I've got to look for a common factor. So I can see I've got 3B and A, but the problem is the signs are different. So BC equals minus 1 times ED. So therefore, BC is parallel to ED. So, because I've got two sets of parallel lines, BCDE is a parallelogram. So moving on to question 24, it says ABCD is a parallelogram, and it says CE is equal to CF, and it says prove that y equals x. So from this, what we then need to do is do this. Now we can do our working out on the diagram, that's usually fine now. So because this triangle of CEF is a isosceles triangle, that this angle here is also going to be y. So working out what this angle here is going to be, well, that's going to be 180 minus 2y. Then to work out what this angle here is going to be, then that angle there is going to be 360 minus two sets of 90, so minus 90 minus 90, minus the angle of C, which is 180 minus 2y. And what I end up with is minus 2y. So this angle here is negative 2y, which you might think is a little bit, well actually no, it shouldn't be minus 2y because I've forgot my bracket, so that should be plus 2y. So then from this, what we then got is that we want to prove that y equals x. So in parallelograms, opposite angles are equal. So therefore 2x equals 2y, and that is from BAC equals B, and there isn't a, oh, BCD. And from this, if we divide both sides by 2, I end up with x equals y, or y equals x, and there is my final answer, and I've proved that y equals x. So looking at question 25, it says that AC is the diameter of a circle with center O, CTS is the tangent to the circle, B is the point on the circumference of the circle such that BC equals BT, and angle BTS equals Y. And the question A is asking us to prove that the angle CAB equals 180 minus Y, and it says give reasons for any angles that you write down or calculate. So from this, what we can then work out is that this angle here, which is BTC, is going to equal 180 minus y, and that's because angles on a straight line. And it's going to be absolutely fine for you to write. You don't need to go through the proof, just straight line would be fine. So from this, we then know that this angle here is going to be the same, so BCT equals BTC, because they are angles in an isosceles triangle. And as this is a tangent, then this angle here, so BCT, is going to be the same as CAB because of the alternate segment theorem, in which I think examiners are recognizing that if you write AST, they will get what that means. So this angle here is, well, if this angle here is 180 minus y, then this angle here is going to be 180 minus y, and so this angle here is going to be 180 minus y. So therefore CAB equals 180 minus y, which is what they asked me to prove. Moving on to question B, it says you are given that angle ACB equals 20 degrees. Work out the value of y. You must show your working, which may be on the diagram. So ACB, so ACB, so this angle here is the one that is 20 degrees. So from this, what we can then work out is what this is going to be. Well, we know that this angle here is going to be 90 degrees because it's a triangle inside a semicircle, because AC is the diameter of the circle. It's a straight line that goes from one end of the circumference to the other through the center. So then from this, what we've then got is we've got 180 minus y, which is one angle, plus 20 plus 90 equals 180. So from this, what we've then got is we've got 180 minus y, and if we take all of this over to the side, we end up with 70. So therefore, y equals 110. Moving on to question 26, it says in the diagram AB is equal to BC, and it says prove that ABCD is a cyclic quadrilateral. So if ABCD is a cyclic quadrilateral, then opposite angles equal 180 degrees. So therefore, angle CBA plus ADC equals 180 degrees. So this is the proof that I'm going to be using. So from this, let's have a look at what is going to be the case. Well, this angle here is also going to be x because CAB is a isosceles triangle. So this angle here is therefore going to be, oh, I don't know why I've put that line there, so let me just get rid of that. So this angle here is going to be 180 minus 2x divided by actually 180 take away 2x. So from this, what I've then got is then 180 minus 2x plus 2x equals what? Well, then from this, well, if I do 180 minus 2x plus 2x, the 2x's cancel, so I'm just left with 180 degrees. So therefore, the parallelogram, or the quadrilateral of ABCD is a cyclic quadrilateral. And the reason for that is because I've then proved that the opposite angles do add up to 180 degrees. Then moving on to our last question, it says that ABC is a triangle. P is the point on AB such that AP equals PC equals BC and angle BAC equals X. Prove that ABC equals 2x. So for this, what we want to do is make sure that we're recognizing what we're wanting to prove. So we're wanting to find this angle here. So for 3 marks, let's have a look at what this is going to be. Well, we know that this angle here, because APC is a isosceles triangle, that this angle here is going to be x. So this angle here, I just call it a different color, is going to be, now again, let me just write down what each of these are. So this angle here is x, as it's an isosceles triangle. This angle here, therefore, is going to be 180 minus 2x. This angle here, therefore, let's just use a different color, green. This angle here is therefore going to be 180 minus 180 minus 2x, which then leaves me with just 2x. So therefore then B must equal 2x. So let's have a look at writing all of this down then. So here we've got ACP equals x, as it's an isosceles triangle. That we know that therefore APC equals 180 minus 2x because angles in a triangle. Therefore that angle BPC is going to equal 2x angles on a straight line. And angle PBC also equals 2x, as it's an isosceles triangle. There we go. Now for B, it then says you are given that AB equals AC, find the value of x. So AB, which is this line here, is equal to AC, and the question is therefore asking us to find the value of x. So therefore then what we've then got is this angle here must also be 2x. So I've got 2x plus 2x. Don't know where that 2's come from with that plus sign being there. Plus 2x plus x equals 180. So I've got 5x equals 180. And if I do 180 divided by 5, I get an answer of 36 degrees. So x equals 36 degrees. And that concludes the end of this revision video.